Dear learners, welcome to the topic ionization energy. In this topic, you will be able to learn the followings. Explanation of the term ionization energy, the factors of ionization energy, the trend of ionization energy across a period and down a group, the electronic configurations and group finding of elements from successive ionization energy data. The explanation of the term ionization energy. Ionization energy is the energy needed to remove the most loosely held electron from 1 mole of gaseous atom. You have to remember, from 1 mole of gaseous atom to produce 1 mole of gaseous ion, each with a charge plus 1. The things to notice about the equation: the state symbol states should be gas and the unit is kilojoule per mole. For the element X, 1 mole of gas atom to 1 mole of gas ion plus 1 charge and electron lost. If you give example for carbon is solid at room temperature pressure, but for the ionization energy you have to convert it to the gas, then 1 mole of gas ion will be produced from 1 electron lost. This is the first ionization energy. From the 1 charge carbon positive, another electron is lost. That is the second ionization energy, and similar for the third ionization energy. So the successive ionization energy increases. Third one has the highest from these three. The reason is that more energy is needed to remove electron from the positive ions. The magnitude of ionization energy depends on the distance of the electron from the nucleus, the number of positive charge in the nucleus, the degree of shielding or screening, and the last one, spin pair repulsion. I'm explaining these 4 factors one by one. The first one, distance of the electron from the nucleus. Distance increases, the less amount of attraction force to the outer electron to the nucleus. So in a group up to down, ionization energy decreases due to the greater radius or greater distance. The charge on the nucleus, greater the charge on the nucleus, the greater attraction force with the outer electron across a period, left to right. Ionization energy increases due to the greater nuclear charge. Screening or shielding. I'm explaining the diagram here. The nucleus and the outer layer is an attraction force, but the attraction force decreases due to the repulsion by the electrons of inner shells. So shielding increases. More electrons in inner shell, greater the shielding. So if we give example, potassium has more inner shells, potassium has less amount of first ionization energy than sodium. Spin pair repulsion, this is very important. If you perform the electronic configuration of oxygen, the 2px has spin pair. Due to this spin pair, the outer electron is easier to lose. So for the first ionization energy of oxygen decreases due to the spin pair repulsion. The first ionization energy of the third period of element, sodium to argon, the overall increases, and 2 exceptions, magnesium to aluminum and phosphorus to sulfur. Overall increases for the elements sodium to argon. Nuclear charge increases, greater attraction, higher amount of energy is needed to lose electron. Magnesium to aluminum. Aluminum has lower first ionization energy. If you perform the electronic configuration, the last electron is 3px, which is higher energy level, easier to lose electron. Phosphorus to sulfur. Sulfur has lower first ionization energy. For phosphorus, 3p sharp shells are singly filled, but for sulfur, 3px orbital has electron paired and the paired electron repel. The first ionization energy of group 2 elements, if we see here, beryllium to barium, decreases. 2 reasons. First one is the radius, another one is the shielding. Both are increases, so ionization energy decreases. This is the last point, very important, using ionization energies to work out which group an element is in. In this case, 5 successive ionization energy is given. The first to second increases, second to third higher. There is a big jump. So 2 electrons in the outer shell of this element, and it is present in group 2. Thank you very much for watching this video.